So we've done simplifying and we've done proving some identities, and the final one we need to deal with is solving equations. So if we have that in this first example, sec theta equals negative 2.5, sec theta is the same as 1 over cos theta, so that equals negative 2.5. And now I want cos theta to be the subject, so I just need to rearrange this so that it's 1 over negative 2.5, and 1 over negative 2.5 is negative 2/5. It doesn't matter whether you can spot that in your head or need the calculator, it makes no odds at all, or negative 0.4 if you prefer. And now I just need to solve it. So theta equals the inverse cos of negative 2/5. So inverse cos of that answer equals, and at this point it's worth pointing out I've got a very small interesting number, 1.98, because my calculator is in radians and the question is in degrees. So I just need to, as with all of the other questions, make sure my calculator is in the right mode. Oh. And then we get a slightly more sensible answer. Cos inverse of negative 0.4 is 113 degree, 113.6 degrees. 3 significant figures or more is absolutely fine. Is that all of it though? No, it's not, because we have repeated solutions. So if I go to my cast diagram, 113.6 degrees is somewhere over here. And that means I've got a second answer, which is down here. It's 360 minus 113.6 degrees. So I need to just do 360 minus that and get 246.4 degrees as my second answer. So that's sec theta equals negative 2.5. And if I want to solve the other one, then I've got cot of 2 theta equals 0.6. Same things before. That means 1 over tan of 2 theta equals 0.6. So tan 2 theta equals 1 over 0.6. And that gives us 5/3 for our value for tan 2 theta. And that means that 2 theta is equal to inverse tan of 5/3. So let's just find that out. And it's 59.04 degrees. Except that we're not quite done here either, because I need to find some repeats, but I also need to do some adjusting. So we talked about, instead of trying to solve for 2 theta, if we say for the moment that x equals 2 theta, then x is 59.04 degrees, but my range of potential values has gone from 0 to 360 with theta up to 0 to 720, because I've swapped theta for 2 theta. So my range of values for x is double the range of values it needed to be for theta. So I need to find all of the possible values for x for tan within the range 0 to 720. So our tan graph does this, and it would stop there if it was 360, but it doesn't stop there, it stops here for 720. So I've got 1, 2, 3, 4 different values, and I just add 180 every time. So if I just add 180, then I get 239.04, and then 419 and 599, those are all my different values for x, which is 2 theta. So my different values for theta, well, theta equals x over 2. So theta equals half of all of these. So if I do my original 59 divided by 2, I'm going to get 29.5. 239 divided by 2, I'm going to get 119.5, and 419 divided by 2, 209.5, and finally 299.5. And I'm going to get 4 answers. And it shouldn't be a big surprise we get 4 answers, because 2 theta compresses everything in, so I get twice as many repeats in that same range. So where we would normally find 2 answers in the range of 0 to 360, we've squashed it in, so we'll find 4. And that's it. So hopefully that's been a helpful reminder of all of those things that we've done earlier in the year, but now we can also apply them to sec, cosec and cot as well.